Welcome to Lakshmi's Chemistry YouTube channel. Zaitsev Rule or Zaitsev Rule. According to Zaitsev Rule, in elimination where there are two or more elimination products are possible, the product with the most substituted double bond predominates. For example, I am taking 2 bromobutane, the presence of base. Here, elimination of HBr elimination of HBr takes place. For example, here two types of products are possible. One is CH3, CH double bond, CH, CH3, and one more product is CH2 double bond, CH, CH2, CH3, CH2, CH3. Two types of products are possible. According to Zaitsev rule, the highly substituted olefin is a major product or Zaitsev product. In these two products, 2 butadiene is a 80% form and 1 butadiene is only 19% form. Zaitsev says more substituted olefin is a major product. According to Zaitsev rule, more substituted olefin is the major product. And the next one, Markovnikov rule. What is this? Markovnikov Markovnikov rule. Markovnikov rule. What is Markovnikov rule? In addition reactions of unsymmetrical unsymmetrical alkenes with a reagent, the negative part of the reagent is added to that carbon atom of the double bond which bears the least number of hydrogens. Least number of hydrogens. For example, R CH double bond CH2 plus HX plus HX. Here is also two types of products are possible. If CH2 CH2X plus or CHX CH3. This type of two products are possible if hydrogen halide is addition with alkenes. Here two types of products are possible. According to Markovnikov rule, unsymmetrical alkene reacts with a reagent. For example, you can observe the mechanism of this reaction. HX, an ionization of this HX will give H plus X minus. According to Markovnikov rule, unsymmetrical alkene reacts with a reagent. The negative part of the reagent is added to that carbon atom of the double bond which bears the least number of hydrogens, which bears the least number of hydrogens is a major product. This one is the major product and this one is minor product. According to Zaitsev rule, negative part of the reagent is added to least number of hydrogens containing double bonded carbon atom. For example, I can write the reaction mechanism or CH double bond CH2, the first one plus H plus. Here two types of products are possible, means for example RCH2 CH2 plus if the proton is added to this carbon, here RCH2 CH2 plus is formed. For example, if the proton is added to this carbon, what is happening? Or CH plus CH3, CH plus CH3. This is first one is the primary carbocation and second one is the secondary carbocation. You know that primary carbocation is a less stable compound and secondary carbocation is a more stable compound. The next addition of halogen, the final product is or CH2 CH2X. If the halide ion is added to secondary carbocation or CHX CH3. This secondary carbocation is a more stable carbocation when comparing with primary carbocations. Here the product secondary secondary second halide containing second halide containing compound is a major product. Here, this product is formed from more stable carbocations. This is markovnikov. Simply, we can say that the negative part of the addendum, is the negative part of the addendum adds on the carbon atom that is joined to the least number of hydrogens, that is joined to the least number of hydrogens. Or you can, this is the Markovnikov rule. According to Markovnikov rule, unsymmetrical olefins reacts with a reagent. The negative part of the reagent is added to the carbon atom of the double bond, which bears the least number of hydrogen atoms. This is Markovnikov rule. For example, I can write, for example, you can use only unsymmetrical alkenes. If you can take symmetrical olefins, this rule is not applicable for symmetrical olefins only. This rule is applicable for only unsymmetrical olefins. For example, I can take propene. Propene on reacts with HBr. Propene on reaction with HBr. Here also two types of products are possible. For example, if the bromine atom is attached to this carbon, what is the product? CH3, CHBr and CH3. For example, if the bromine is attached to this carbon, what is happening here? CH3, CH2, CH2Br. This is 2 bromo propane, 2 bromo propane. This one is bromo 1 bromopropane, 1 bromopropane. According to Markovnikov rule, 2 bromopropane is a major product. 2 bromopropane is the major product. This is majorly formed. This is the Markovnikov rule. And the next one is anti-Markovnikov rule. This is the Markovnikov rule. And the next one is anti-Markovnikov rule. Anti-Markovnikov rule. Anti-Markovnikov rule is against for the Markovnikov rule. Same in this anti-Markovnikov rule also, the addition of reagent to unsymmetrical alkenes in the presence of peroxides or light addition of a reagent to unsymmetrical alkenes in the presence of peroxides or light, in which the negative part of the reagent is added to the carbon atom of the double bond. The negative part of the reagent is added to the double bond is added to that carbon atom of the double bond which bears the more number of hydrogens. For example, RCH double bond CH2 plus HX. What is here is also two types of products are possible. One is RCH2 CH2X and RCHX CH3 R2O2 in the presence of peroxides. In the presence of peroxides R2O2. In the presence of peroxides, this one is the major product. This one is the major product and this one is the minor product. According to anti-Markovnikov rule, a reagent is added to unsymmetrical reagent. Addition of reagent to unsymmetrical alkenes in the presence of peroxides or light, in which the negative part of the reagent is added to that carbon atom of the double bond which bears the more number of hydrogens which bears the more number of hydrogens. We can explain the, for example, I'm taking one more example to explain this anti-Markovnikov rule. For example, I'm taking propene CH3 CH double bond CH2. Propene reacts with hydrogen bromide in the presence of peroxide R2O2 or light sunlight H nu sunlight. Here two types of products are possible, CH3 CH2 CH2 Br one product and CH3 CH Br CH3. Two types of products are possible, one bromopropane, one uh, propane and two bromo bromopropane, one bromopropane and two bromopropanes. Here the one bromopropane is 93%, two bromopropane is 7% in the presence of peroxides. What happening if the peroxides are present? For example, we can see the mechanism of this reaction. In the presence of peroxides, the homolytic cleavage takes place on peroxides give two RO dot radicals, two RO dot radical. In the presence of radicals, hydrogen bromide is also give ROH and Br dot bromine radical. CH3 CH double bond CH2 in the presence of bromine radical. In the presence of bromine radical, here two types of products are possible. If the bromine radical is reacts with this CH2 carbon, what is happening? CH2 CH CH2 Br, CH2Br, and the carbon radical is formed. For example, if the bromine radical is reacts with this carbon atom, what happening? CH3, CH, Br, and CH2 dot. This type of free radical is formed. In the first one, this is the secondary free radical. This one is the primary free radical. Already you know the secondary free radicals are more stable than when comparing with primary free radicals. That's why secondary free radicals containing compound is a major product. That is CH3, CH2, CH2Br, and then CH3, CH, Br, and CH3. This is the primary free radical is the less stable. Secondary free radical is the more stable. Secondary free radical is a more stable. That's why the bromine atom is in the presence of peroxides. The bromine atom is added to more number of hydrogens containing double bonded carbon atom. This is anti-Markovnikov rule.